Okay, hello everyone. So today we're going to talk about the key components, which is part of multi-component distillation with me, Winny. Right, so let's review what is key components. Key components is an important components that may be distributed among the distillate or the bottom product. So there are one possibility. In this case, you have A, B, and then A, B is separated into pure A with a little bit of B in the distillate, and bottom product would be majority of B with a little bit of A. So there are one only possibility of separation between A and B in the distillate, in the binary distillation. So of course, in practice, it's not possible to separate A 100% and B 100%. The top product will comprise of component A with impurities B, while the bottom product will comprise of component B and impurities of A. So A and B is distributed in both products, so it is called the key components of in the system is A and B, where A is called the light key component, or LK, which is the light key component is the lightest components that are found in the bottom product, while B is called heavy component, which is the heaviest component that of important concentration and found in the distillate. Okay, so what happens if you have a ternary mixture, if you have three compounds? So there are two possibilities. The first one is the separation would be between A and B, or the separation would be between B and C. If you consider that you want to separate it in between A and B, you will get a distillate with very rich of A, which is almost all of the component A will go into the distillate because A is more volatile than B. And then you will have a little bit of B in your distillate. And that is called, B is as a heavy key in the distillate. Another hand, A, it would be still remaining a little bit in the bottom product, while B and C, of course, most of all would appear in the bottom product. So in this case, A is the lightest component that found in the bottom product. So it can be considered that A is the light key component. Okay, so let's see this one. So this one is we have A, B, and C, but we want to have a product which is, we want to take most of the A and B. So in this case, A and B would appear on the distillate, and with a little bit of B still distributed in the bottom product. And then we have a little bit of C, which is distributed in the distillate, and then most of the C will go into bottom product. In this case, you will see that C would be the heaviest component that present at important concentration in the distillate, and B is the lightest component that appear in the bottom product. So C is the heavy key and B is the light key. So with changing those pairs of the light key, we can have different products and we can have different design for distillation operation. Okay, what happens if we have component mix, four component mixture? So if we have four component mixture here, so that we'll have three possibilities: the separation between A and B, the separation between B and C, or separation between C and D. So the distributed components there, for example, if we want to mostly separate A with the rest of the rest of the heavier component, that in the distillate we will have A as the majority with a little bit of B. Okay, and then of course the bottom would be contain B, C, and D with a little bit of A. So you can say that B is the heavy key component and A is the light key component. And with that side, you can also think about which one is the heavy key component and also the light key component by checking all the separation. The heavy key component, the light key component, you want need to decide which one is the heaviest key and the light key based on your preference of your distillation operation. If you want to have a pure product, usually the most volatile one, usually we use this approach. If you consider, let's say, you want both of them, A and B on the top, C and D at the bottom, then you may consider the separation between B and C. Okay, there's all special case where B, C, and D is really distributed. In this case, B, C, and D is really distributed in the distillate and in the butter product. Okay, so now let's have a look at this one. This one is an example where you have a feed like for 45 normal meter cubic per hour with this top product in here one, and then this is the bottom product. If we look at this one here, and then I think in the distillation column it is specified what is the top product. But normally what you want all of the volatile or the more volatile component would be appear in the distillate. For this case, you can calculate 45 multiply with 8.66 %. You have to change it first from the mole. You have to change it first. Sorry, from the volume, you have to change it into the mole using the ideal gas, PV equal to nRT. So you can get the N like that. So convert it into, sorry, I'll put it like this one. So you got the mole of the products or mole the rate, and then so this is going to be your feed rate. So apparently this example is not ideal. Actually, if you have this feed, you want all of the feed goes into the top product. But in this case, the from the feed, for example, 159 of the propane, only 79.1 goes to the top product, while the other one into the bottom product. Now, if you look at this one, you can see where is the heavy key and the light key. So heavy key is defined as the heaviest key that present in important concentration at the distillate. So this one are important. You have the value from 79.1 into 0.01. So we can consider this I-pentane as the heavy key. On the other hand, over here in the bottom product, they still have considerable amounts, very, very important ones. So because we don't have a very tiny amount that is important, so the definition of light key would be the lightest component that is found in the distillate. So this one would be the light key. Okay. So let's have a look about the key components that we got it from the book, from the table book. So it is convenient to the feed components in order to relative volatility. The more volatile components is called light, and then the less volatile is called heavy. There will be frequently one component, which is called light key component, which is light key component present in the residue in the bottom product in important amounts, while the component lighter than light key present only in a very, very small amount. If all components are present at important concentration in the residue or in the bottom product, then the most volatile is the light key. So if you have very significant amount in your bottom product, so your lightest point would be the light key. Similarly, there will be one component, heavy key component, present in the distillate in important amounts, while component heavier than the heavy key present only in small amounts. If all components are found at important concentration, then the least volatile is the heavy key. Okay, so now just review a little bit example. Let's say we have a fixed component with this VIF at this pressure and temperature, sorry, in the pressure, and then we have to determine the temperature. We know the flow. So what we need to do, we have to calculate the composition over here. And then in this problem, it is defined the light key and a heavy key. In this case, the light key is the component C3 and the HK is the component IC4. So usually the heavy key should come in important amount and the distillate. So you did note with this one. It is small but very important, like 0 point something over here, you multiply. And then you also have the light key over here. So you can assume from here that the in the distillate, the component heavier than heavy key would be equal to 0 because it's not significant. And in the bottom product, on the other hand, the component lighter than the light key, you can also consider 0. By using this one, you can calculate your mass balance in the distillate and in the bottom product, and then using appropriate temperature and pressure, we can also find the K value in the feed, a distillate, bottom product, and also the relative volatility. This will be important for the next case, for our problem next one, which is how to calculate the stages in a multi-component distillation. Okay, I hope you can get some things that I see. So here you can see that this is, if we calculate it, it would be, the distillate would be enriched with this one, the lighter component, lighter than heavy key, and the bottom would be full with the bottom product compared to light key. Okay, and then this is how you add the K value of each one by assuming the temperature, the top and the bottom, and then using, the temperature, the pressure, then you can determine the K value for each compound and at each stream. Okay, I hope by listening to this video, you understand the concept of key components, the concept of light key component, where the light key is the lightest component that found in the bottom product or in the residue, and the heavy key component is the heaviest component, that the important concentration that you found in a distillate. By knowing the light key and the heavy key component, we will be able to obtain the specific information that we need to calculate the stages in order to get the separation of those multi-components. Okay, thank you, and I'll see you in the next video. Okay.